Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now I am going to explain the topic hybridization in ethene. What is ethene? This is part 3. And part 1 I have explained the hybridization in methane and part 2 ethane. Before reading to ethene, first please read methane and ethane. Now you can see what is ethene. Ethene structure having double bond between carbon and single bond between carbon and hydrogen. How many hydrogens are there? 4 hydrogens are there. But the question is why the double bond takes place, how the valency of carbon satisfied. You know carbon has 4 valency. But if you see the electronic configuration, here 2 electrons are unpaired. If unpaired electrons in orbitals, that is here px py orbital, that means they have capacity to form bonds. That means here carbon would be divalent, but till now here only we know carbon has tetravalency, or you can say tetravalent. So then here you can say the carbon is tetravalency. So here there should be excited state of carbon. Now electronic configuration of carbon, that is 6 atomic number, and here 1s2 2s2 p2, and where the outer shell 2s2 p2 4 electrons, but here one is paired electron, and that is s orbital has paired electron, and px py, that is only one or electron in each orbital, because here out of 3 orbitals 2 electrons are there, so one should occupy 1 electron each. Now since it is tetravalency, 4 valencies should be there, 4 bonds are formed, 4 valencies should be satisfied. That is why in excited state it is thought that 1 electron jumps from 2s orbital to here 2pz orbital. That means here 1 electron, sorry here not you write here, 1 electron jumps from s orbital to z orbital. That means here already it jumps. Now how many unpaired electrons? 4 unpaired electrons. In 4 unpaired electrons they are capable to form bonds. Yes, they can form bonds. But what type of bonds? Here it can form with S, here px, py, pz. Px, py, pz, they have same type of energy, same energy level, and there is no problem. But when you come to s orbital, that is less energy than p orbital, then what happens when what is the bond formed with s orbital? Here it should be less energy. But according to experimental observation, then here it is found that the valency, the bonds which are formed with hydrogen and with others, they are equivalent bonds having equivalent energy, having equal length. Then what happened? Since S is less energy, there should be one bond should be less energy and bond length should be less. But when you find in experiment, it is proved that here what are the bonds formed, that is equivalent. Now the question is ethene. Ethene 4 hydrogen attached to carbon, they are equivalent. And here you can see if they are equivalent, then what happened? Here scientists thought that there should be some hybridization takes place. What is hybridization? I told already in sp3 and hybridization example methane. Hybridization means the combination of atomic orbitals and redistribution of energy in equivalent level, equivalent orbital, and that is called hybridization. And here only sp2 hybridization takes place, because here since it is double bond, then you will think here one is sigma bond and one is pi bond. Then pi bond how it will form we will see later. Then scientists thought in ethene sp2 hybridization takes place. sp2 hybridization means spx S, Px, Py. That means here it is not involved. Pz, that is not involved. It remains as it is. It is called on-hybrid orbital. And here if 3r undergoes sp2 hybridization and it forms sp2 hybrid orbital. Then how? Here this is S, this is the S, and here this is the Px, this is the Py, 2Py, 2Px, each having one electron, and 1, 2, 3 orbitals joined S, 2P. So 3 orbitals, then this is the sp2 hybrid orbital. See, here one can guess the angle should be 120, then this is trigonal shape, and here sp2 hybridization. And now each orbital is called sp2 hybrid orbital. And what is remaining? Pz remaining as it is. It is not undergoing hybridization. It is not undergoing to any changes, any excitation or any bond formation. Then what happens to here? And now Pz contain one electron also, and that is unhybridized orbital which contain free electron, and this is the sp2 hybridization where each one is known as sp2 hybrid orbital and containing one electron each. Now we will see how the bond form with hydrogen and carbon to carbon, carbon to hydrogen, and what type of sigma bond, what type of pi bond, and how many sigma, how many pi bonds are formed. We will see, and now how they will hydrogen will join with the or overlapped hydrogen orbital, that is s orbital of hydrogen will overlap with the sp2 hybrid orbital of the carbon. In ethene, there are 2 carbons. Each carbon undergoes sp2 hybridization. sp2 hybridization, that is triangular shape. Now you can see here, this is the sp2 hybridization of carbon, and each one is called sp2 hybrid orbital. Here one carbon, here one carbon, 2 carbons are there. This is carbon 2, this is carbon 1. After that, when they come to close each other, then this and this, they will overlap each other. That means sp2 of carbon orbital, sp2 sp2 orbital of carbon, and here sp2 orbital of carbon, they overlap each other. Now see, they overlap each other. And then what happened? Here overlapping takes place, and this is your sp2 and sp2 overlapping. Now each orbital, sp2 orbital of your carbon to this side 2, they overlap with 1s orbital of hydrogen. That means 1s means spherical, symmetrical, having one electron. So this sp2 orbital of carbon overlaps with this s orbital of hydrogen. Here also 2, here also 2. That means 4 sides, 4 orbital overlapping takes place, that is sp2 and s overlapping. So see here, this is sp2 overlapping, and this side also sp2s overlapping, 2 hydrogen, this side 2 hydrogen, all are sp2s overlapping is sigma bond. See, all are sigma bonds, but this is only sp2 overlapping, and this is sp2 of carbon, s1s of hydrogen, and also this also give sigma bond. So here 1, 2, 3, 4, these 4 are same as it is, that is sp2s, and form sigma bond. In middle, carbon and carbon, this is sp2 overlapping, and here also one type of sigma bond. Now here what happened, where I told you one pz orbitals which is unhybridized, which is left, which has also one electron. Now you put this pz here in this carbon also pz orbital there, and each containing one electron. Now you can say overlapping takes place. You know pz like this, px px, py py, pz pz, So PZ overlapping takes place containing each electron which is on hybridized orbital, and now two lobes form. You know, when pi bond is formed, here upper and below there are two lobes formed. These two lobes combinedly gives one pi bond. Now here after overlapping of PZ, that is lateral overlapping, we can say lateral overlapping where pi bond is formed. This is pi bond. Out of two you can say one is sigma, one is pi bond, nothing else is there. Here pi, here sigma, or sigma pi, you can write your choice. This is sigma, so it is pi, and this also sigma, this also sigma, sigma, sigma. Here sp2s overlapping takes place. Now you can see here this is sp2. sp2 overlapping is sigma, pz overlapping gives pi, sp2s overlapping is sigma, then 4 sigma 1 2 3 4 as it is where sp2s overlapping, 1 sigma where sp2 sp2 overlapping, here sp2s overlapping, here sp2 overlapping. So how many total sigma? 4 plus 1. Total sigma bond is 5. Out of 5, 1 is formed sp2 overlapping up to carbons. Other 4 are sp2 orbital of carbon, 1s orbital of hydrogen form sigma. So total bond sigma 5. One pi bond is formed, that is pz overlapping. pz overlapping, this is lateral overlapping and it gives us pi bond. So this is the structure of ethene where 4 sigma which is same as it, that means here sigma between carbon and hydrogen, and 1 is sigma between carbon and carbon, 1 is pi between carbon and carbon is formed. So I hope it is clear to you, and hope you will subscribe my channel BL Das Short and Sweet in Chemistry. Thanks for watching my video. Thanks again to all. And one request to all, when you will read this ethene, first of all you read methane, then ethane, then this ethene. Then it will be easy for you. Thanks again.